Hi, I'm Lisa Spooner, and this lesson, Public Key Infrastructure Concepts, is part of the CompTIA Security Plus training course. And in this lesson, we'll start with an overview of what public key infrastructure is. Then we'll talk about the public and private key pair and what the difference between the two is. Next, digital certificates and how they solve the problem of authentication. Then we'll talk about the certificate authorities, otherwise known as the CA. Then, with just those few concepts under our belt, we can start on how PKI works. Next, we'll talk about registration authorities and how the RA does some administrative tasks for the CA. Then, certificate revocation lists, recovery agents, what to do if the key gets lost, and key escrow. And we'll talk about the difference between key escrow and recovery agents. Now, this lesson talks about the core concepts of public key infrastructure. That's what you'll need to learn before learning the real-life implementations of PKI and certificate management that we'll discuss in a future lesson. First, that overview I promised you. PKI is a two-key encryption system. Having two keys, the word for that is asymmetric. Now, it's important to note that PKI is a framework, like a guideline, that different systems, vendors, and technologies can interpret and use to provide authentication and confidentiality in their data transmissions. So it's a set of rules, right? And one being that you have to have two keys. The key length is up to you, the encryption algorithm you use is up to you, but you have to have those two keys. So PKI provides confidentiality with that encryption, and it provides authentication with the use of digital certificates, which we'll talk about in a minute. But first, let's start with those two keys. So let's say you want to send a secure message to Alice. Now, Alice has a key pair, a public key and a private key. And those two keys are mathematically related. They were created by a special algorithm at the same time. So let's see how this works. You request Alice's public key. Now that's public, meaning anyone can see it, anyone can have it, so she sends it to you. Then you use that public key to encrypt the message that you want to send to Alice, and you send it back. Now, so far not so secure sounding, right? No, just wait. Anything encrypted with this public key cannot be decrypted with that same key. It has to be decrypted with the pair to it, the private key, which only Alice has. So she uses that private key to decrypt the message and read it. Now this is great for confidentiality, right? Nobody can intercept that message in between and decrypt it because they don't have Alice's private key. But how do we really authenticate? I mean, someone could be pretending to be Alice using a different public-private key pair, send you their public key, decrypt the message with the private key, and you'd never be the wiser. Well, that's where digital certificates come in. So now we get to authentication. Digital certificates associate a particular public key with an individual, a company, an organization, whoever it is that owns that public key. Digital certificates are issued by a certificate authority. So what's contained in those certs? Well, a common certificate standard is the X.509, and it contains fields like when is a cert valid? Not before this date, not after this date. What algorithm is used for encryption? What's the public key? That one's important, right? Oh, and the issuer. That's that certificate authority. Let's talk about that now. A certificate authority is a server responsible for issuing, revoking, and distributing digital certificates. This is often a trusted third-party organization. Commercial examples are DigiCert and VeriSign. But companies and organizations can create their own in-house CA. For example, the Windows Server products offer tools to create a local certificate authority. The CA also stores the public keys in a directory that is available to anyone that wants to verify your certificate. Now that we have added the CA, that secure message transfer gets even better. Again, you want to send a message to Alice. Here's how it would look using public key infrastructure. Alice has already registered and has a digital certificate from the CA. You request Alice's certificate from the CA. Remember, one of the CA's responsibilities is distributing the certs. Or Alice could send it to you herself. It's public. How we know it actually belongs to Alice is that it's signed by the CA. And we trust the CA. So you get the certificate. You encrypt your message using Alice's now verified public key that's contained within the cert. You send it to Alice. No one can decrypt it along the way without Alice's private key. She uses that private key, decrypts the message, reads it. Now I know that I said that we'll be talking about PKI implementations in a future lesson, but I just wanted to show you real quick a place where PKI is used in our daily lives. Come with me. Public key infrastructure is used all over the web in the form of SSL certificates. Now, verifying who you're interacting with is especially important when shopping online. So here I am at trainsignal.com, and if I add a product to my cart and begin the checkout process, if I right-click on the checkout page, click Properties, and then Certificates, I can see that SSL cert. If I go to Details, here's version 3 of that X.509 standard I was talking about. There's a ton of information here. The issuer is VeriSign. The subject is actually who owns the cert, that's TrainSignal. And here's that public key. Beautiful, isn't it? Okay, I just wanted to give you a quick peek. Let's go back. Now let's talk about registration. Registration authorities help PKI even more by acting as a kind of secretary or administrative assistant for the CA. It takes some of the workload off of the CA. When the RA is involved, you interact with the RA server directly. You provide the RA with your information and your payment if it's a third party. The RA verifies this documentation before confirming that the CA can issue and sign the certificate. The RA does not sign the certificate itself. Now, when you send this information to be verified, one thing that you might send them is your public key. If the key pair was generated locally, you would need to provide your public key. This is more secure than if you relied on the CA to create that key pair. Now, creating the key pair locally or the CA creating it, both ways are common. For PKI to work, digital certificates need to be kept up to date and valid. To keep track of certs that can no longer be used, the CA maintains certificate revocation lists. The CRL is published hourly or daily, really often, and the CA sends the list to anyone that subscribes to it and makes it available to anyone that requests it. Some reasons a cert might be on the CRL? Well, it's expired, or it's been revoked. Say it has a, compromised private key. Or an HR reason like the key owner no longer works for the company. Or the company itself has changed names, physical address, CNS, or any reason prior to expiration, it's revoked. And this is permanent. A new cert would have to be issued. Sometimes a cert is just suspended. Say an employee takes a leave of absence. In this case, the reason for revocation listed on the CRL will be certificate hold. The cert owner or an authorized administrator can request the cert be revoked. So it's very important. The second that you find out that a key has been compromised or any other reason, you send that revocation request ASAP. And it's important to know that verification happens at this stage of the game too. The CA verifies that the request is from the cert owner or someone verified to make this request before it's put on the CRL. So, what if a key gets lost? PKI allows for the option of maintaining a secure key recovery server and an authorized person or persons who have access to it. a key recovery agent is an actual person, and that person is authorized to retrieve keys in certain cases. Now, the recovery agent isn't recovering keys that have been lost, as in let loose in the world, but more like forgotten. Say a user's key was stored on a local computer and that computer crashed. In that case, you could get the user up and running again on a new computer after recovering their private key. The system of having a recovery server and recovery agents is usually used in locally maintained public key infrastructures. I think it goes without saying that this server must be kept extremely secure. In some cases, there is actually more than one recovery agent, and both must be present to retrieve the lost key. That's a great example of separation of duty, don't you think? When recovering the key, the recovery agent must provide the following things: proof that the request is from an authorized recovery agent, the name of the key owner, the time the key was created, and the issuing CA server. So having a recovery agent isn't something that you want to think of after the key's been lost, but a system you want to have in place before it does. Again, this whole system is optional. If no recovery system is in place and a key gets lost, a new cert must be issued and the old one placed on the certificate revocation list. Like the key recovery server, the key escrow agency, or key archival system, keeps secured copies of private keys. That's called key escrow. But this time, they are not available to the recovery agent. Instead, they are available to law enforcement during a formal investigation. And in theory, a warrant would be needed before accessing the private keys. Sometimes there are multiple databases with only part of the private key kept in each. That's that separation of duty again, making the private key even more secure. In 1995, the U.S. government tried to mandate that copies of all private keys be kept in escrow, but they soon gave up on that demand due to public outcry and conspiracy theories. Today, key escrow is optional, but not uncommon. And that's it. But before we wrap up the lesson, here are the new terms that were introduced in this lesson and the ones that you'll want to have down pat for the exam. First, public key infrastructure. PKI is the framework for encryption that associates a public key with a verified person or system. Next, public key is the part of the key pair that is available and distributed to the public. The private key is the part of the key pair that is secret and used only by the key owner. Certificate authorities. CAs are responsible for issuing, revoking, and distributing digital certificates. And those are certificates that verify whom a public key belongs to. Then we have registration authority. The RA verifies the prospective key owner's identity and sends it to the CA to issue a cert. Certificate revocation lists. That's a frequently published list of certificates that are no longer usable for a variety of reasons. Recovery agent is a person who is authorized to recover lost private keys in certain cases. And last, key escrow, keeping secured copies of private keys for law enforcement purposes. All right, what have we covered in this lesson? First, we did a quick overview of what public key infrastructure is. Remember, there was an emphasis on the word infrastructure. This is not one particular technology, but a framework used by many technologies. And each vendor can interpret this however they choose. And some still aren't compatible with each other. Next, we talked about the public and private key pair. Remember, the public is public, the private is private, and the pair is mathematically related and generated at the same time. Then, we talked about digital certificates, some of the info contained on them, and how they are issued. Then, we discussed the big bad certificate authority and how it has the most important job within PKI. Then I showed you a nifty diagram of how PKI works to send a secured message to Alice and only Alice, and you can still sleep at night knowing that no one else can read it. Then we talked about registration authorities and how it helps offload some of the grunt work for the CA. Then I talked about certificate revocation lists. Those are lists of certs that can no longer be used. Sometimes the CRL contains information about why the cert was revoked, and when the last time communication with that cert was considered secure. Last, we talked about recovery agents and key escrow, both ways to back up your private keys, one for you and one for the government. I hope you enjoyed watching this lesson on public key infrastructure. I know I enjoyed creating it. Thanks for watching.